What is astrobiology? For thousands of years, people have stared up at the night sky and pondered the possibility of other life forms. It might exist within our solar system. Could it be on a different blue planet orbiting a different star? No one was aware. But these ideas have been expressed in literature, scientific endeavors, and faiths all around the world. Thinking about how life first appeared on our planet was not just the province of philosophers, but also of common people. Every civilization and culture has a foundational creation story that captures the profound resonance of the origins issue. What about right now? Have we made any progress so far? Astronomers have now reduced our knowledge of the universe's beginnings to minute fractions of a microsecond after the Big Bang. However, scientists are still unable to pinpoint the precise moment and circumstances under which organic matter first underwent the transformation from non-living to living, or to provide a satisfactory description of life. Around 50 years ago, civilization started to expand into space, first with robots and subsequently with people. Basic questions regarding the long-term adaptability of living beings to various conditions remain unresolved while our species continues its cautious spread into other planets. For instance, we frequently consider Mars as a potential second home, but we are unsure of the effects of spending extended periods of time there. In fact, the pull of gravity on Mars is about 1/3 that of Earth. Such inquiries are addressed by astronomers. However, what precisely is astrobiology? You won't regret following me to learn more about it. Let's begin by only responding to the query, describe astrobiology. Astrobiology is the study of life in the universe, as one may easily infer. Do you believe it to be a simple task? I'm sorry to disappoint you, but one of the most difficult topics we can research is life in the cosmos. But first, let's go back in time to the creation of the phrase astrobiology. Only in the 1950s, during the space age, was the term astrobiology first used. It was used to describe both the study of the hunt for extraterrestrial life and the research of the biological effects of space missions. Astrobiology later gained popularity after being introduced to the general public and the scientific community by renowned scientist Carl Sagan. As a result, astrobiology is today understood to be the branch of study that investigates the beginning, distribution, and development of life throughout the cosmos. These disciplines include biology, geology, astronomy, physics, chemistry, engineering, and sociology. Astrobiologists can work alone on specific scientific problems, but they frequently collaborate with scientists from other fields to look at complicated problems that no one field can solve on its own. In other words, when we think about life, we immediately begin to picture big intellectual beings, or perhaps little green men, invading our planet on their technological spacecraft. This, however, is science fiction. Do you wish to discover the truth regarding the existence of life in the universe? So, if we wish to make any assumptions about life, what might it be? Looking at our own planet first is one of the logical places to start, perhaps the only one. The only planet that is currently known to support life is Earth. You'd probably argue that this is fairly evident. What then do astrobiologists do? They employ a technique known as the grand analogy. To put it briefly, they draw on their understanding of the history and evolution of life on Earth. They then attempt to comprehend how to generalize that knowledge to other cosmological systems, like our solar system. Because of this, the key to advancing astrobiology is studying the history of life on Earth. What do we know about life on Earth at this point? We are aware that life first appeared on Earth some 3.8 billion years ago, most likely in the deep oceans. We are aware that the Earth was different then than it is now. Why do we mean that? We mean that you might not have been able to breathe if you had been present, because there was no ozone layer and almost no oxygen. This indicates that there was significant radiation present, which leads us to the conclusion that the initial forms of life had to be anaerobic in order to survive the radiation and develop without oxygen. Because the radiation doesn't reach deep waters, that is why we believe it came from there. These early hints, liquid water and organic molecules, provide us with information about the prerequisites for the emergence of life. What we believe is that the oceans moved the molecules, and finally the appropriate molecules met at the appropriate time and location. Astrobiologists believe that is how life first appeared. Additionally, we see how diverse life is through observing the various organisms we study on a daily basis. We discover a new type of organisms every day that exist in environments where we previously believed no life could ever exist. Extremophiles is the term for them. An organism with optimal growth in environmental conditions deemed severe in the sense that it is difficult for a carbon-based life form, such as all known life on Earth, to thrive is called an extremophile, from the Greek for extreme and love. In the planet's evolutionary past, these organisms have dominated. Extremophiles have existed for more than 40 million years and have persisted in thriving in the harshest environments, making them one of the most prevalent life forms. These microbes can survive at temperatures higher than 100 degrees Celsius. They also help us define the limits of life since they dwell in lakes or rivers that are extremely salty or acidic. Space is one of the most hostile environments, therefore astrobiologists wondered if life could exist there. For this reason, they have carried out numerous in situ experiments, sending bacteria and other microorganisms into space and placing them outside the International Space Station, where they are exposed to the real space vacuum and the real space radiation. After standing there for several months, they discovered that many of the organisms survived. It makes us wonder where else in the universe life might exist, thus this is something of a revolution. So, naturally, our own solar system is where we start by looking. We start by gazing at the moon after traveling there. However, we put our attention on other things because there aren't these teams and no life there. Please like or subscribe to the channel before reading what we learned about life in our solar system. Jupiter's moon Europa. Did you know that water ice makes up the majority of Europa's surface? Many experts believe that there is a layer of liquid water, or even an ocean, beneath the frozen surface, which the heat from the flexing keeps from freezing. How are we aware of it? Geysers that erupt through ice fissures on the surface, a weak magnetic field, and disordered topography on the surface, which may have been distorted by ocean currents spinning beneath, are all signs of this ocean. It is possible that hydrothermal vents and ocean floor volcanoes can be found at the bottom of this ocean globe. On Earth, these traits frequently support extremely diverse and rich ecosystems. Therefore, could life have existed on Europa? Saturn's moon Titan. The only moon in the solar system with a sizable atmosphere is Titan. Nitrogen, a significant chemical element used in the creation of proteins in all known forms of life, makes up the majority of the atmosphere. Recent radar observations have found the presence of liquid methane and ethane rivers and lakes, as well as likely the presence of cryovolcanoes. Volcanoes that erupt liquid water as opposed to lava are known as cryovolcanoes. This implies that Titan, like Europa, has a liquid water resource below the surface. Despite Titan's distance from the Sun, it's too cold for liquid water there. The abundance of compounds there have sparked conjecture that life forms could exist there, potentially with chemistry fundamentally different from that of terrestrial creatures. Mars. One of the solar system's planets that is closest to Earth is Mars. It has a 24.5-hour day, seasonal polar ice caps, and a wide variety of surface features that were shaped by water over the course of the planet's history. Mars is a particularly intriguing prospect for life because researchers found a lake beneath the southern polar ice cap. Methane was also discovered. This is astonishing because, despite the fact that the source of the methane on Mars is yet unknown, it may be produced by living processes. We must only maintain our optimism and work toward retrieving data from Martian soil, perhaps with the incredibly helpful assistance of persistence and inventiveness. As one might expect, Despite being a relatively new topic, astrobiology has a bright future. The planning of present and upcoming space missions by organizations like NASA and the European Space Agency is significantly influenced by astrobiology research. A lot of recent missions have been launched with the goal of investigating the planets in our own solar system and looking for evidence of past, present, or life's ancestors, including Mars. The Cassini mission, one of the most well-known missions, improved our knowledge of Saturn and its moons, such as Titan. The James Webb Space Telescope is currently being prepared for launch, which will enable us to start looking for habitable planets outside of our solar system. Since the beginning of the field's evolution, it has been recognized as essential to share the findings and excitement of astrobiology. Different approaches have been used to achieve this goal. One component was a shared platform represented by the biennial Astrobiology Science Conference, which now draws over 800 scientists from over 30 different domains. The conference has seen increases in attendance at meetings in 2000, 2002, 2004, and 2006, and it continues to be a place where researchers are encouraged to push the envelope. What about the future of astrobiology? Species, ecosystems, and models for origins that have greatly expanded our understanding of the known environmental constraints of life and provided important insights into the early Earth. An important new piece of the jigsaw has been contributed thanks to laboratory research, which has also helped to improve models and provide more hints. Astrobiology will soon reach whole new levels of understanding thanks to missions. Astrobiology will continue for a very long time given the enduring fascination with the issues surrounding the origins and distribution of life. Here's where the video ends. Thank you everybody for watching. Do you have any other questions concerning astrobiology? Tell us in the comments section below and see you on the channel again soon.